Hello everybody, and welcome to our next session for Algebra 2. This is our 20th lesson on our COVID journey since we've seen you last before we left for spring break. This session should be done the week of May the 4th, and your work will be due on May the 8th. So make sure that you're keeping up with that and getting it turned in to your teachers along the way. Okay? So today we're going to start solving exponential equations. So we have a property that works for equations when we have them. And notice it tells us if b, which is our base, is a positive number other than 1, it cannot be 1, then b to the x equals b to the y. If and only if, remember that means these go back and forth, x is equal to y. So if x is equal to y, this is true, and if this is true, x is equal to y. So what we want to do with our examples, we want to look at the bases that we have, and notice I have a base here of 4 and a base of 2. Well, notice they're not both the same. Like up here, they have to both be the same number b. So we want to look to see if we can turn one of those bases into where they're the same. So if you recall, 4 is the same as saying 2 squared. So I can replace my 4 with 2 squared, and I would have 2 squared raised to the x minus 1. Well, remember when we have a power raised to a power, we're really multiplying. So if I multiplied 2 times 2x minus 1, that would give me 2 times x, which is 2x, and 2 times 1, which is 2. And now notice that my two bases are both 2. And if my bases are the same, then I know that the exponents must be equal as well. So I know that 2x minus 2 would be equal to x plus 5. We can continue to solve, subtract our x from both sides, and we'll get x. Add our 2 to both sides, and we'll get 7. So then we know that x is equal to 7. Okay? Now I have a few more examples just to kind of go through things with you. These will go much faster than the examples we had from our last lesson. Notice on number 2 that I already have my bases that are the same, so a lot of our work is already done. So we know automatically, right away, if bases are the same, exponents must also be the same. So we know that 2x minus 1 is equal to x plus 2. Subtract my x over, and I get x is equal to, when I add 1 to both sides, 3. So some of them are super fast, super easy. Some a little bit more challenging. That's why I have a few more examples. But for you to see, that's basically what we're looking for, is bases to be the same, set the exponents equal to each other. Okay? So notice on number 3, things change up a little bit. We have your favorite fractions, so we want to make sure we know how to deal with those. And I have a base of an 8. Now, what I'm looking at is my base of 8, and over here, this being a 16. Well, I can't take 8 and square it to give me 16 because it's 8 times 2. But I do know that 8 comes from 2 times 2 times 2. And if 16 is 8 times 2, then I know 16 comes from 2 times 2 times 2 times 2. So I can rewrite my 8 to be 2 to the third power raised to the x minus 2. And I can write my 16, remember we know when we have 1 over a number that originally that exponent would have been negative, so 16 would be 2 to the negative 4. 2 to the negative 4 would give me the 1 over 16 that we started with. So if I take care of my exponents here and multiply those, I get 3x minus 6. Sorry, that's an ugly 3. I'll clear that up for you. 3x minus 6 and 2 to the negative 4. Now that my bases are the same, exponents are equal, So 3x minus 6 must be equal to negative 4. Solve, add 2 to both sides. 3x, when I add 2, add 6 to both sides. When I do that, I'm going to get 2. And then when I divide by 3, I get 2/3. Okay, so just because as soon as you see that fraction, know you're going to have a negative exponent to deal with that fraction. All right. So one last one to go through. This is a short video for you guys. Thank goodness, right? I have 9 and 27. Again, 9 times 3 gives me 27, but not 9 times 9. So it's not a perfect square. So I'm looking at the 9 and I'm looking at the 27. And I know that 9 is the perfect number that comes from 3 times 3. And 27, its factors are 3 times 3 times 3, which is where we got 9 times 3 from. So we can rewrite those. 9 is 3 squared, and that's raised to the x plus 1. 27 is 3 cubed, and that's raised to the x plus 4. Multiply your exponents. Whoops. So I have a base of 3 raised to the multiply 2x and multiply 2. Here, when I multiply by my 3, I get 3x and plus 12. Once my bases are the same, exponents are equal to each other. So 2x plus 2 is equal to 3x plus 12. Move my 2x over and I get x. Subtract my 12 over and I get negative 10. And that's how we solve our exponential equations for this section. We have lots of other problems that we're going to do with different kinds of exponents in the next coming lessons. So yes, we're going to dive deeper into these exponential and log equations as we go. Make sure you jump on your teacher's Google Classroom Hangouts if you have questions, or send us an email or a message on Google Classroom so that we can help you and do the best we can to make sure that you know what you're doing and can get your assignments done. Okay? Assignments, you'll have a handout, or you can choose to do Desmos. Either one you want to do is perfectly fine for me. Check with your teacher if she wants you to do something different. I did not pick a IXL for this assignment. If I happen to find one, I will add it to the Google Classroom as well. Okay? So y'all take care and stay safe. Keep continuing to do your social distancing. All right? Bye.